Here we go. We have a question peak element. So you have given an array where no two adjacent elements are same, and we need to find the index of the peak element. A index is considered to be a peak element if it is greater than the adjacent elements, means the element present on left hand side and on the left on the right hand side. If there are multiple answers, return any one of them. The output will be true if your returned answer is correct, otherwise false. And note here is consider the element before the first element and after the last element to be minus infinity. So you have given this example. In this case, it is given that the index 5 0 1 2 3 4 5, this is a peak element because this is the greater than the left side element and on the right side element. And in this case, this element is the peak element. Yeah, then this element is the peak element. So there are multiple answer, you can return any one of them. In this case, this element is a peak element, it is greater than this, and on the right hand side you can assume minus infinity, so also greater than the element on the right hand side. So this is the question. Let's try to build the approach. I first solve this question using order of one time by comparing each and every element. Then after looking at the expected time complexity, I analyzed that we can solve this question using binary search. So let's try to solve this question using binary search. So I have taken this example. First of all, our L is here and R is here. Then the middle element will be 0, 1, 2, 3, 4, 5, 6. 6 by 2 is 3. 0, 1, 2, 3. So L here, R here, then middle is this. Is it greater than the left side element? Yes. Is it also greater than the element on the right side? No, this is not the case. So we are sure that this is not the case. Then what we can do is we have to check is uh, is this element greater than the element present on is this element greater than the element present on right hand side? No, this is not the case. Then what we can do is this element is not the peak element. We can check is this element the peak element. How do we check? So we just need to check is the element on the right hand side, is it greater than this? If it is greater than this, means this can be our peak element. This can be our peak element. So just update your L to mid plus 1. So our L now pointing to 7. Middle is this. Is it the peak element? Yes, this is the peak element. So we have found our peak element. We can return any one of the answer. L is here, R is here. Let's talk about this test case. What is the middle value? So let me write the index is here. Then this is the middle point. So is it the peak element? No, this is not the peak element. Is the element on the right hand side greater? Yes, the element on the right hand side is greater. Means the element present on the right hand side can be our peak element. So just update your L to mid plus 1. Then this. Is this the peak element? Yes, this is the peak element. Then let's talk about this test case. We have this. Is this the peak element? No. Is the element present on the right hand side greater? Yes. So the element present on right hand side can be our peak element. So we have this. Then we have this middle point. Is the middle value? Is the middle value our peak element? Yes. So before doing the binary search, we can write our if cases. So what is the if case first? So first of all, let's talk about this. If n is only 1, we have only single element. So minus infinity here, minus infinity here. Means we have a single element, and if n is 1, then we will return index number 0. If n is 1, we will return 0. And we have one more thing, 4, 3. We have this. So if n is 1, that's the thing. But if n is greater than 1, is the element present on 0th side? Is the element present on 0th? Is it greater than the element on 1th? Yes, means the element on 0th is the peak element. So this is the second if block. And well, what will be the third if block? Let's suppose we got this minus here and minus here. Let's suppose we got this. N is not 1 and this element is not greater than the element present on 0 on 1th. So 0 is not the peak element. Let's check for the last element. Is the last element the peak element? So we know it is greater than element present on right hand side. But is this element also greater than element present on left hand side? Yes, this element is greater than element present on left hand side, means our answer is n minus 1, the last index. So now let's code this. We got n, we have this if blocks. 0th element is greater, return 0. If the last element is greater, return the last index. Then we have simple binary search. This is our binary search. Then we got this. Is the middle value greater than on the left hand side and element present on right hand side? Just return mid. Else the element present on right hand side greater, means our right hand side element can be the answer. So just update your L to mid plus 1. Else we have a element present on left hand side that is greater than the middle value. So our element present on left hand side can be the answer. So just update your R to mid minus 1, because it is given that no two adjacent elements are same. Then at the end, if we have not find any index, so just return minus 1. This is not the case. If you don't write anything here, this will work, but we have to return something, so that's why we have to return, although this line will not execute. So now let's submit this. And let's talk about time and space complexity. As you already know, time complexity is log n, space complexity is constant. Code is given in the description box. And if you guys have any doubt, feel free to ask in the comment section. Give this video a thumbs up. And we have successfully solved this question. Thank you all for watching.